Hi, hello and welcome to Solving Equations Involving Radicals Day 1. We are going to take 2 days to take a look at this because this is a very critical component and it's algebraically laden. So we're going to go slowly through it to make sure that you understand what you're looking at in the algebra. In the next 2 days, I'm going to be reinforcing what you're seeing here in the algebra by using Desmos, and we'll begin there in our first example. So our first example is going to be in table form, this. So you notice that your x's can be written in here. I've simply used 15 so that it goes off of the page, and so it has the illusion of a line. You don't have to use 15 in your table. In fact, you'll see it won't fit there either. Start with 1 and go to 2, 5, and 10. And you'll be able to fit that into the table that you've been given. All right, and now we'll go ahead and open that up for the graph so that you can see what it looks like graphically. So far, what we've looked at here is we've looked at several different ways that you can use graphical representation to represent these square roots. We saw it a couple of days ago in inverses, and now we're seeing it here again. So graphically, you can definitely see what you're looking for in these particular problems, and they're a very good way to help you understand if you've gotten the correct answer or not. And that's important, especially if we're asking you to find the answer algebraically. It's always good to be an honest cheater. And what that means is that if I'm asking you to solve it algebraically, go ahead and graph it so you can know what the answer is. And that way you know exactly what you're looking for in the results of all of your algebra. And then there's no more guesswork. The calculator can be a useful tool even if we're expecting you to show your work. And that way you know that if you got to the answer, which in this case is 10, then you know you've done your algebra correct and there's no more guessing. So use the calculator as a tool even when we ask you to solve using algebra. All right? So you notice that here is your solution where the two lines intersect one another. All right, now we're going to get back to algebra, and we're going to solve it using an algebraic method. So I'll go ahead and write that as the square root of b minus 1 equals 3. In order to get rid of the square root, I got to square both sides, and that gives me b minus 1 equals 9. Add 1 to both sides, and I get b equals 10, which was confirmed by the work that I had done previously in Desmos, which is work you will show in your calculator or do in your calculator, even though you will be expected to solve it algebraically. All right, question number 2. We'll go ahead and head back to the graphing emulator right now. Close this one down and open this one up. All right, so here are your table values again. Start with 0. And that will get you through all the way for your table, so it'll fill in properly. And there is the graph represented here by the purple and the red lines. What we're looking for here is a place where they intersect, and they intersect one another at 8. So you can utilize this to help you see where the solution lies. All right, now let's reinforce that with the algebra. So we get 2 equals the square root of x divided by 2. First step here is going to be to square both sides, and I get 4 equals x divided by 2. Because it's division, I'm going to multiply both sides by 2, and that's how you get your answer of x equals 8. Another reason why it's important to back things up graphically is that there will be times where you have extraneous solutions, and you can see clearly which solution is real and which one is extraneous by looking at the graph. So in the next several examples, we're going to have to understand that we're looking at solutions which may not actually exist in the actual graph, and those are known as extraneous solutions. And we always have to check our work to make sure of what we're getting, okay? All right, we'll begin here by squaring both sides to get rid of the square root. Negative 8 minus 2s equals 0. Add 8 to both sides. Negative 2s equals 8. Divide by negative 2. And s equals negative 4 is the answer I get. Now what I'm going to do is I'm going to utilize Boolean algebra to help me determine whether this solution is extraneous. So follow along as this script proceeds. Notice here what I'm doing is I'm putting the solution in and I'm storing it for x. Then I'm going to rewrite the equation using the test key. You'll see that as soon as I get to the place where I need to find my equal sign. And once I hit enter, I get a result. That result will either be 1 or 0. 1 is true, 0 is false. That's how you check to make sure that your answer is not extraneous. I'd like you to try question number 4 on your own right now so that you can practice utilizing this method. Please use Boolean algebra to determine whether you have extraneous solutions in your answer. All right, hold off on question number 5 for just a second. We're going to move on to question number 6. These are getting a little bit more complicated, so I'd like to go through them with you so you can see what it looks like. You'll go back and do question number 5 after I'm finished with this particular portion. Okay, now we got to remember back to a couple of days ago when we talked about fractional exponents and how they switch into radical form. So that's x, the a over b, can switch into a radical of b, x, a, like that. So that means that this is a fancy term for a square root. So now I'm going to go ahead and rewrite this as x minus 5 equals 3x minus 11, and I'm going to write it as a square root. And that's going to help me recall that to get rid of a square root, I square both sides. Now I'm going to go ahead and multiply this out as a perfect square trinomial. Oh yeah, they're back. X squared minus 10x plus 25 equals 3x minus 11. I'm going to add 11 to both sides. I'm going to subtract 3x to both sides. And I'm going to get x squared minus 13x plus 36. I'm hoping that's factorable. What two numbers multiply together to make 36? And how do they add up to negative 13, negative 9, negative 4? Because this coefficient is 1, I can use that mental factoring shortcut. X minus 9 times x minus 4, which means the resulting answers are x equals 9 and x equals 4. I'm not done here, so I need to go in and check for extraneous solutions. All right, we're going to check this using Boolean algebra. Make sure that we're correct on it. All right, so you want to store your first answer of 4 as x. Remember to use a test key to set your equal sign. And then I'm just typing in the equation exactly the way I see it in the original problem. I'm utilizing my fraction key to make a fraction. Again, you could replace that with a square root if you wish. Notice that the result is 0. That result is false. Now I've gone up and I've changed my x to a 9, and now I just grabbed that previous equation. I didn't bother writing it again, I just grabbed it one more time. That means my solution 9 is correct and my solution 4 is extraneous. I don't know why I boxed that. I'm sorry. I'm just going to go ahead and box both of them for you. But the answer is 9, not 4. Okay? I will try this one more time with question number 8, and then you'll have 5 and 7 to do on your own. Be ready to share your results with me tomorrow at the beginning of class. All right. So I'm going to square both sides on this because there's no way for me to move that radical to isolate it, and I definitely am not dealing with x as a fraction. We'll get to that later on in Unit 6. So I'm just going to square both sides. Remember, there's two numbers in here. There's an x and there's a square root of 2. So they both get the exponent. So I get 18 minus 3x squared, a perfect square trinomial. We'll deal with that in just a second, but I want to focus on this side first. X squared times 2 is what I get over here. All right, so now I'm going to multiply this out, and I get 324 minus 108x plus 9x squared. And that's equal to 2x squared. I'm going to bring this over because there's less over here, and that gives me my answer more quickly. I'm going to rotate this around, and I get 7x squared minus 108x plus 324. I'm hoping this is factorable, but I know that it's not, and that's why I did this one with you. Okay, so I'm going to go ahead and employ the quadratic formula here, and I get the opposite of b, that's 108, plus or minus the square root of b squared minus 4ac, which is 2592, divided by 2a, which is 14. Now, this becomes a simplified number. Sorry about that. 108 plus or minus 36 square roots of 2 divided by 14. All even, so let's take out the GCF of 2, and I get 54 plus or minus 18 square roots of 2 divided by 7. We'll go ahead and employ Boolean algebra one more time to see our answer. Clear out our previous script, and we'll run this one. All right, so since our number is not very friendly, we're going to use that fraction key to fill it all in, 54 plus or minus. I'm going to do this twice, obviously, once for the plus and once for the minus. Square root of 2 divided by 7. Store as x. Now I'm going to type this in exactly the way it was in the original problem, utilizing my test key. And the first answer is false. Now I'm going to grab that previous number because it's so complex, because all I have to do is change that positive to a minus. And so I'm going to move back over there to 54 plus 18 and change it to 54 minus 18. Now I've done that. Now I've changed the number. I'm going to go back up and grab that previous equation as well. Saves a lot of time. You don't have to retype stuff. And you can see that your solution is 54 minus 18 square roots of 2 divided by 7. So Boolean algebra is very useful in this particular case. You'll notice that graphing is also very useful in these cases. You would be able to see it if you were to graph it as well. Remember, you've got some problems that you need to do, so take some time now to practice them. Come ready tomorrow with any questions that you might have over this particular concept.